Okay, this is just a lesson for those people. It's going to be quite quick and brief. It's not a particularly difficult lesson to just look at the basic sine and cosine graphs. Basically, we have to be able to get them on our calculator and be able to draw them, and we have to have a sense of why sine graphs look the way they do. So basically, if we go to Desmos, and if you throw sine, I have to set this up. Make sure that your calculator is in degree mode. Mine defaults to radians every time. So if I go sine of 0, it comes up as 0. If I go sine of 90, it comes up with 1. If I go sine of 180, it comes up with 0. If I go sine, and so on. Okay? And sine of 270 comes up with -1, and the sine of 360 comes up with 0 again. So those values create the sine graph. And we deal in degrees, and I'll talk to you about why we deal in degrees with sine and cosine graphs eventually. So basically, if I just show this path, right, I just sort of play this slider around. So a sine graph starts at 0, 0, so sine of 0 is 0. It maxes out at 90, at 91, goes through 180 at 0, maxes out at 270, and then finishes at 360. So that's like one whole cycle of the sine graph, right? And negative sine, if you want to look at negative sine x, just this thing here, it's just the flip. It goes from 0, then -1, then 0, then +1. So it's just the flip of the +1. So that's basically why the sine graph looks the way it does. It's pretty basic. But why is it sort of tied to degrees? Why do we deal with degrees? And that's got to do with something called a unit circle. Now, a unit circle is simply a circle that has a radius of 1. A radius of 1. And within that radius of 1, we can draw a right angle, a bunch of right angle triangles, right angle triangles all the way through this. And when we're dealing with right angle triangles, we're basically dealing with sine and cosine, and tangent, if you will, but we're dealing basically with sine and cosine. Now, the unit circle, this is from the other class, but basically unit circle is affiliated with our sine and cosine graphs. And if we take a look at this, make this our reference angle right here, and then we have side opposite and side hypotenuse, which basically, if I just blow this up a little bit, see it a bit better. If this is my reference angle, the sine is basically opposite over hypotenuse. Well, we know what hypotenuse is. It's 1. And the hypotenuse, or the opposite, which is basically this height here, is given by this point, right? Because this is how far up we've gone. So that's 0.682. Now, if you try to find that angle, so we do sine of -1 is equal to basically this messy thing, 0.682 over 1. And if we do that on our calculator, if I do shift sine -1 of 0.682, it will give me 43 degrees. So that's what that angle is, 43 degrees, right? Now, as I move through my unit circle, so if I make this a thing here, 43 degrees, which, see, that's where we are on the one note. Now, if I move my angle through the unit circle, right, and then I get to that angle, this angle here, being at 90 degrees right here. See, at 90 degrees, the sine opposite over hypotenuse is just going to be 1. Because that distance there is basically 1 over 1. And if I move it through to 180, it's 0. So sine of opposite over hypotenuse is 0. And if I move it to 270, sine of opposite over hypotenuse is -1. And so it all has to do with the unit circle. All has to do with the unit circle and creating these right angle triangles. Now, you don't need to know this. This is just a little bit of extra information about why we're dealing with degrees when we deal with cosine and sine graphs. And it has to do with its association with the unit circle. Okay? So, same thing applies to cosine graph. Now, cosine graph, we go to Desmos. Cosine graph looks different, so it looks like this. Because if you try cosine, cosine of 0 is 1. Cosine of 90 is 0. Cosine of 180, and so on. Right? So now, instead of starting at 0, we start at 1. And then we go through 0. Then we go minimum of 180, which is at -1. Then we go through 270, which is 0. And then we go 360, which is at 1. So there's the full cycle of a cosine graph, right? It starts at 1. It goes kind of down and back up and completes itself at 360 degrees. And again, if you want to look at the path that it follows, oops. So it starts at 1, goes through 90, hits the minimum point at 180, goes up to 270 at 0, and then finishes at 360. Okay? So that's a complete cycle or period. Now we know it's a period of cosine. So sine starts low and goes up and then back down. Cosine starts high and goes down and then back up. That's basically it. Now the tricky part comes in when we want to basically use our calculators to sort of create these graphs. So using the calculator is a bit interesting because we have to set the window up to basically go from 0 to 360. So basically you go Shift F3, which is your window. Now you can hit this trig function, which will put things in degrees and so on, but that's not what I want. I want you to sort of change this x minimum to 0, go to a max of x of 360. Now the rest of it should probably, I'm going to go back to that window because remember that the amplitude is just 1. Those y values are probably far too big. So I'm going to go maybe even just -2 and 2 for the y values. Exit draw. Oh, yeah, I do need an equation in here. Sine x. Draw. See, there it is. Okay, so you've got your, and then you can go G-sub and you can find your max, and you can go G-sub and you can find your min, and you can find your x-intercept, and you can find your well, there's more than one x-intercept, isn't there? G-sub, whoops, G-sub. So there's one there, and there's one there. In the 360 degrees, it goes through the x-intercept 3 times, basically at 0, at 180, and 360. So those are the kinds of things that you need to be able to do with your calculator, and we can do the same thing. Once I've got my window set up, I can have a good play with this, and it works quite nicely. So you can use the trig function, but I would set up your window to look something like this initially, and just have a play with that if I want to do cosine instead of sine, x, draw. Yeah. And then again, you can go to your G-sub and you can find all your x-intercepts. There's only 2 in this one. You can go and you can find your max. Oops. Go and find your x. No, doesn't want to find that. Maybe I need to make my window. Yeah, probably go to -1 maybe, just so it gets it in there. Give me my minimum. Sure, it'll give me my minimum. Doesn't want to give me my max. There it is. I don't know why it's showing a max of -2.66. Oh, that's not where the graph starts. Okay, that's fine. The max goes past the y-intercept, so that's what that's showing. And y-intercept, which is where the graph starts for us at 1. What else can I find? That's it, probably. That's it. So that's how you use your graphing calculator. And that's probably all you need to know about sine and cosine graph for the first. Now, also, if you want, you can, just before I leave, the unit circle also obviously associated with cosine graph. But instead of using opposite over hypotenuse, obviously cosine uses adjacent over hypotenuse, right? And so again, you can find those reference angles in the unit circle using cosine, but you're now using adjacent over hypotenuse to find that angle using cosine. So again, it's the same principle, and that's why we deal with degrees.